Okay, CNN provided a television channel targeted to individuals waiting in supermarket checkout lines. The channel showed news, short features, and advertisements. The length of the program was based on the assumption that the population mean time a shopper stands in a supermarket line is 8 minutes. To test this assumption, a sample of actual mean waiting times from 120 shoppers showed a sample mean waiting time of 8.5 minutes. Assume the population standard deviation is 3.2 minutes. Okay, notice that the wants us to test to see if the actual mean waiting time differs from 8 minutes. In that case, to be different would be to be greater than or to be less than. So this is going to be a two-tailed test. We'll assume that the average time is 8, and the alternative then is that it's not. Step 2 is a sampling distribution. Again, this is a two-tailed test. We'll assume the average is 8, but we'll have a decision line on both ends in this case. Our alpha is 0.05, so in a two-tailed test you split alpha over 2. In this case is 0.025. And if I would use a table to get the z-scores for that, at the lower end it would be a negative 1.96 and a 1.96 on the upper end. Standard error would be the standard deviation, which was given as 3.2, and then divided by the square root of the sample size, or square root of 120. That calculates out to 0.292. Step 3 is our rejection rule. We will reject H sub 0 if our test statistic is less than negative 1.96 or our test statistic is greater than 1.96. In other words, we're far enough to the left to show that the average is actually less than 8, or we're far enough to the right to show that the average is greater than 8. And then to calculate our test statistic, we had an 8.5 average from the sample, and standard deviation or standard error divided into that difference gives us a 1.71. Step 5 is do not reject. Seven or 1.71 is not less than negative 1.96, nor is it greater than 1.96. So I will say since negative 1.96 is less than 1.71 less than 1.96. So do not reject does not mean that we have proven the null true. It just means that we don't have strong enough evidence to show it's false. See, we turn next to running the same test using a p-value. Again, we will set up the null and alternative hypothesis in the same way. And rejection rule is we'll reject H sub 0 if the p-value is less than 0.05. Now, to get the p-value, I am going to look at my 8.5 and find its location, which is 1.71. So 8.5 is, let's say roughly around here. Actually a little further out than that, because its test statistic, or the number of standard deviations to the right of the center, is 1.71, and that's less than my critical value, 1.96. So when I want to calculate a p-value, I'm going to base it, first of all, on this calculation here, this value that I get from the table, the probability of getting anything less likely than the 8.5. Of course, this is a two-tailed test, and we're going to end up doubling this value. So I'm going to look up the 1.71 in the table, and keeping in mind that the table reads to the left of whatever the z-value you're looking up. And that value in the table is going to be 0.9564. So to calculate my p-value, I'm going to take 2 times, 2 again because it's a two-tailed test, 1 subtract 0.9564, and that's going to give me 0.0872. 0.0872 is greater than 0.05, so we do not reject. And again, we will always be consistent with these two approaches to running the test, whether you're going to compare a test statistic to a critical value or where you're going to compare a p-value to the level of significance. You always will end up concluding the same thing. Do not reject doesn't give us the information or the evidence that we need to say the null is wrong, but we're not willing to say it's true either. If we try to claim that we've proven that the null is true, then we open up the possibility of making a type 2 error, and we're not trying to control type 2 at this point. So we just safely say do not reject. There's not enough evidence to reject the null. I'm not willing to make any statement of fact at this point concerning this problem.